Hi, in this video I'll be covering questions 1 through 6 on the test review for test number 3. For numbers 1 and 2, you're asked to evaluate and explain what the solution tells you about the polynomial. If we want to evaluate our function at 1, then we're going to store 1 as x. So we type in 1 store x, enter, and then type in our function. X cubed minus 3x squared plus 5x minus 3. Make sure I typed it in right. Hit enter, and the value is 0. So we would state that f of 1 is equal to 0. Your job is to remember that if it's equal to 0, then that means that we can create the factor x minus 1. So we will say that f of 1 equals 0. Therefore, x minus 1 is a factor. Next, we need to evaluate negative 3. So 2x cubed plus 4x squared minus 5. Make sure I've typed it in right. And the value is negative 23. So we say that f of negative 3 is equal to negative 23. Now what we're supposed to understand based on our factor theorem is that this is the way we can find a remainder. If our remainder is 0, then we can create the factor. If it's not equal to 0, then it's not a factor. So we need to say that f of negative 3 does not equal 0. Therefore, the factor x plus 3 is not a factor. All right. Next, for number 3, you're asked to write a polynomial in standard form given some real zeros. So I'm going to be doing all of this work on a separate sheet of paper, and you'll need to do the same for a test. For number 3, in factored form, we have a factor x minus 5 quantity squared, the factor x minus a half, which we have to do bottoms up for, so that factor will be 2x minus 1, and the factor x plus 3. Remember, you always write zeros in the form x minus the root, okay? The reason why I have this quantity squared is because it says multiplicity 2. So that means you'll need squared on that quantity. Your job is to write it in standard form, which means you need to expand it out by multiplying. So x minus 5 times x minus 5 gives us x squared minus 10x plus 25. When I multiply the quantity 2x minus 1 times x plus 3, I get 2x squared. 6x minus x makes positive 5x. Negative 1 times 3 is negative 3. And when I get to the point where I have a 3 by 3, I'm actually going to use a box. Just kind of helps to keep it more organized. All right, so 2x squared times 2x squared is 2x to the 4th. Let's see, minus 20x cubed, 50x squared, 5x cubed, minus 50x squared, 125x, minus 3x squared, positive 30x, minus 75. And then I should have my like terms diagonally. So my polynomial would be f of x is equal to 2x to the 4th minus 15x cubed. 50x squared and 50x squared cancel, so minus 3x squared. Add these together, plus 155x minus 75. Now, you should never stop until you have verified your answer. So I'm going to go to y equals and type in my function. 2x to the 4th minus 15x cubed minus 3x squared plus 155x minus 75. Make sure I've typed it in right. Minus 3x squared plus 5x. All right. And I should see the behavior at behavior on the x-axis mimic what I know about the zeros. So we can see it bounces off at 5, and then it crosses at a half, and then at -3, so it looks good. So make sure you verify your answer before moving on. All right, so I'm just adding that to the key. Make sure that you transfer your answers to here, but that all your work is very clear because you're going to have to attach that to your test as well. All right, next for problem 4. All right. So for number 4 here, we have to remember that for any of these that have a conjugate pair, we need to include that. So for number 4, we've got the polynomial f of x equals the quantity x plus 3, x minus 4i, and x plus 4i. Please remember that you can do the box for this if you like, but you should be able to quickly multiply it out and get x squared plus 16. The reason is when you multiply this last term, we get negative 16i squared, which is negative 16 times negative 1, becoming positive 16. We have to distribute that with a x plus 3 as well. So when I distribute, if you want to do box, feel free. X times x squared is x cubed plus 16x. Your inner plus 3x squared plus 48. Then please make sure when you write it in descending order. So x cubed plus 3x squared plus 16x plus 48. Now to check our answers, remember we should only see it cross one time, and that should be at -3. Oops. I don't even know why I did that. 3x squared plus 16x plus 48. Hopefully it will only cross at -3. And you can see that that is the case. That should help us to know that our other two are imaginary. All right. Next, for number 5, let me write this answer up here. All right, for number 5, we should recognize that 2 minus 3i is a root, so therefore its conjugate 2 plus 3i is also a root. So when I write this in factored form, I'll start with my real value, x minus 3, then x minus the quantity 2 minus 3i, and x minus the quantity 2 plus 3i. So 2 minus 3i and 2 plus 3i are conjugates. What should happen is when we distribute this negative, we'll end up with x minus 2 plus 3i and x minus 2 minus 3i. So if you look here, it's x minus, but they kind of end up switching, and those are your conjugates, right? So next what I would do is go multiply these 3 terms by using the box method. If you've figured out by now what terms you really don't, which ones are going to cancel out and which ones you don't need to multiply, then by all means that's awesome. But I'll do this for the sake of those that need to see it. So when we multiply these terms, we get x squared minus 2x, 3xi minus 2x, plus 4 minus 6i minus 3xi, positive 6i, and minus 9i squared. Negative 9 times negative 1 for negative I squared, which will give us positive 9. Our 6i terms cancel, our xi terms cancel, and we should end up with x squared, we've got like terms here, minus 4x, and then 4 and 9 should be combined to get 13. We then need to distribute it over the term x minus 3, so you can use box method or just double distribute. I'll just distribute here, x cubed minus 4x squared plus 13x minus 3x squared plus 12x minus 39. So we should end up with a polynomial f of x equals x cubed minus 7x squared plus 25x minus 39. I'm going to check it. X to the third minus 7x squared plus 25x minus 39. And we should hopefully see it cross just at positive 3 because that's our real value, x minus 3 was our factor. So looks good. So that's how you should feel confident about it after checking your work. Notice if I'm doing it, you should be doing it on the test as well. Make sure when you transfer your answer to your paper, you don't make a mistake with any terms though. All right, next for number 6. You notice that we have an irrational root, the square root of 3. We're going to have to also include negative square root of 3 because of our irrational root theorem. So for number 6, we should have in factored form x minus the square root of 3, x plus the square root of 3. X minus 2/3 will become 3x minus 2. And then lastly, whenever we have a 0 of x minus of 0, then the factor x minus 0 will simplify to just x. So I'm going to go ahead and take care of these two terms first. We've multiplied these out several times in class. Hopefully you've caught on that your middle terms will always cancel. So you have x squared minus the square root of 3x, positive square root of 3x, and minus the square root of 9. But the square root of 9 is 3. So these irrational terms should cancel out, and you should get x squared minus 3. And that's for these two terms. Now when I multiply these two terms, I just need to distribute the x. So that would give me 3x squared minus 2x. You can do the box method if you prefer, or just distribute 3x to the 4th minus 2x cubed minus 9x squared plus 6x. Let's see. 3x to the 4th minus 2x cubed minus 9x squared plus 6x. All right, so that should be my function. Let's go to y equals and check it. Make sure I've got it typed in right. All right, and we should at least see it cross at 2/3. It's going to be tough, but the square root of 3, it's irrational. So we should see, oh, sorry. Can't even see what I'm doing. We should see that it crosses at between 1 and 2, but because we have negative square root of 3, it should cross on the other side at negative 1.7 approximately. And 2/3 is located between 0 and 1, so let's see what happens. So between negative 1 and negative 2, between 0 and 1, and between 1 and 2. Looks good. And in fact, if we had 0 in here, we could do second trace 5 just to make sure. And of course it crosses at 0 also. And there's that negative 1.73 value we were talking about for the square root of 3. All right, so we have verified that that is correct. So 3x to the 4th minus 2x cubed minus 9x squared plus 6x. Notice all of these functions start with f of x. Please do not miss that and leave it off on your test, or it's not even a function. Thank you. The next video will cover problem number 7.